So let's now see the common causes of flakiness. The first thing is the timing issues. The issues might be due to network or some changes in the UI, HTML ID changes. So the frameworks might claim that no waiting is needed, but really you need to make sure that you have the dynamic waits and no hard-coded waits or thread.sleep lines, and you should always check for edge cases and make sure your test is resilient in those. And that's a fundamental problem. The problem is, when do you know the UI is finished updating, or a button appears in 1 second and sometimes 3 seconds. So that's where the elements on the page you need to observe and make sure you have the dynamic wait. And then you need to know when the network request gets completed. So you need to wait for a clue on the screen or some other network response, and then wait until you get that response. And figuring out how long to wait is the fundamentally hard issue here. And the network also causes the chaos, and anything your app touches, the UI might talk to a DB, database, or APIs, or some other remote endpoints, and it might even make a GraphQL request. So that's what you need. And another thing is it might be due to infrastructure, your environment, or could be some external service. And another thing is the resource constraints. This is the limited test environment capacity. Suppose you run your test in test environment, but your environment doesn't have the Jenkins agent, or your machine where you run is not having that capacity to run those tests in parallel, or if there is any inherent limitation in the memory used by the computer, the machine, whether it's Unix or Windows machine, or the CPU is not that much powerful, you might end up in the resource constraints. So sometimes you might have experience when you are working on a project, you might need to tune your environment for many weeks. So you need to make sure that your test environment is really have that capacity to handle those parallel test runs. And another reason is the version mismatches occurs between the application and the test environment application. And there are some dependency conflicts, and there are some backward forward compatibility issues, and you need to make sure that your library version or any protocol and any dependency that your test uses, whether it's software or environment, need to be aligned with what you need for that test. You might be using a Lambda version, for example, deployed in production, but your test environment has a outdated version. We need to make sure that all the dependency, the APIs, the database refresh is the latest one. So you make sure that the tables have the columns and they are not outdated. And of course, the rare framework bugs, they are very rare, and you need to patch those. Don't apply the patch actually. If found, you should report to the upstream. So those are the framework bugs. And the library glitches, for example, the dependency library or the shared library need to be up to date, and any bugs in the library might impact your test, and it might cause it to behave in a unfamiliar pattern. That's what we call the flakiness. So many of these problems can also happen in the production. So that's what the flaky tests make valuable. Sometimes flaky tests, they are the signpost to real problems. So you cannot just ignore a flaky test and just take it as a low priority. The flaky test may actually point to real performance issue or some other bug that might be even reproducible in production. So thanks for watching. We have seen a lot of useful information in the video. So if you like this video, please share it and subscribe to the channel, and drop your thoughts in the comments below. and what is your experience with the flaky test, and do you have any other ideas on how you overcome or managed it successfully. Thank you for watching this video and happy testing.